All right, so we're gonna talk about the two-dimensional figures. So two-dimensional figures, what are they? So far we have spoken about one-dimensional figure, let's say line and all, but now we're gonna talk about two-dimensional figures. Two-dimensional figures is majorly, let's say, a figure which is formed by joining the multiple lines. So you see out there that let's say the basic one, the most basic one is to start with is a polygon. So you see that this is a polygon. Now in this polygon you have how many sides? You have 1 2 3 4 5 6 sides. So all these sides, the end of these will be joined and they will be closed over to form it as a polygon. So that's the polygon. Now what all different type of polygon structures are available? Think of it like, let's say it could be a random, it isn't supposed to be like this only, it could be like this as well. The only consideration is that you should have them joined, and think about it, the start and the end should collide. So for example, it's ending here, it's getting started for this one, and then it gets finished here, and then it gets start here, like that it is. So there is no intersection as well. Now think about it, this one looks a little odd, but that's also a polygon because everything is start and the end are connected. This one, a regular rhombus, I guess. So that's also a polygon, an example of a polygon. Now let's talk about the things which are non-polygons. So I'm in here. Now if you check this out carefully, right, see this. So where is that? This piece is not at all connected. This piece is not at all connected. So that's not a polygon. Now think about this one. This is left open. So that's also not a polygon. If it is connected with this, then it will become a polygon, no matter what the structure it is. Now this one, because it has an intersecting line, so that's also not a polygon. Okay, so we learned about the polygons and the non-polygons. Like what are they? Now let's dive a little deep. Let's try to get inside this, okay? Polygon. There are two things out here that's happening. There are two categories. The one is convex, the other one is the concave. Now what is the difference between these two? That's basically, you will see this term in the science as well when they talk about the light and all. So now this thing, majorly what it is mean. So for example, I just drew this triangle here. Okay, so now this triangle, if you keep on expanding this on either side, you will see that these lines will not intersect each other. You can very well expand these three lines in any direction. Like this can go up, this can go down, and this can go this side. Now this is called, this particular piece is called convex. This type is called convex. Now the next one we have is the concave. What do we mean by the concave? Concave means, for example, this red one, that's my structure. Okay, that's like a fish, an amoeba fish. Okay, now in this structure, if I try to extend in this direction, it's fine, it's not intersecting. If I try to extend in this direction, that's also fine. But now think about it. If I try to extend this one, so that goes inside, which is not a convex thing, that becomes the concave. So that thing is called concave polygon, when you can draw the line inside like this, which intersect each other. So now that's the concave one. Next, the most basic piece over here is this one. So what do we mean by this one actually? Right here, if you carefully observe, this is an example that you have a pentagon. So this PENT and gun is like pentagon, means it is supposed to have 5 sides. 1 2 3 4 and 5. Now when you see all these angles which are highlighted here, what do I mean by them? So what happens is that a pentagon can be equilateral. So what do I mean by equilateral? Equilateral means all these sides that you see, they're little, I just draw them little not with a scale, with my hand. Otherwise all these sides has to be same if you want them to be equilateral. So that's the thing. Once they all have 5 sides same, all the 5 sides are same, or all the sides of a polygon are same, that will become an equilateral polygon. Now what happens is that, let's say along with the side you have all the angles which are also same, like in this case all the angles are same, then that becomes equiangular. So in the mathematic term, what do we call that? For the equilateral we say all sides are congruent, means all sides are equal, or we say all angles are congruent for the equiangular. Now how do we classify the polygons? So for example, in this particular case itself, let's say you have a polygon. So what type of polygon is that? If you extend that in direction of A, B, C, D or E, it's not gonna collide anywhere. So it's not gonna intersect with anything. So that way it'll be a convex polygon. Now the polygon which is convex, equilateral or equiangular, that type of polygon will be the regular polygon. So this is called the regular polygon. Now we can ask that, then what do we mean by the irregular polygon? What are they? Like if I have to do any irregular polygon, then what are they? Okay, let's try to take an example using this one. Okay, let me just get my pen. So for example, I'm right here. Now check this out. I'm just joining that. This is little odd, but let me just try to clear it. Okay, let's try to join this. Okay, now think about it. In this polygon, or maybe let's try to take a better shape. I'm just trying to draw one example here. So let's say my example is this one. Now if you carefully observe that, right, if you carefully observe, let's think for the time being that all the sides have the same length, like A, B, C, D, E and F. Let's think of that all the sides are having same length. Let's say all are equal length. Okay, so when they all are equal length, okay, I will say that my polygon is when they all are same length, okay, I'll say my polygon is equilateral. Okay, I got it. That's a equilateral polygon. But now think about it. Is it convex? Okay, let's try to see. This goes in this direction, it goes in this direction, this goes in this direction, this goes in this direction, this goes in this, but this can go inside. It should not go inside. It should always go outside. It cannot be inside the polygon. The moment it is inside the polygon, that will become a concave polygon. And a concave polygon is only the convex can be the regular. A concave cannot be regular. So it's an irregular polygon. It is a polygon. Or rather I would say that there are how many sides? 1, 2, 3, 4, 5, 6. So this is a hexagon. But that's not a regular hexagon. That's an irregular hexagon. So because of this convex property, it become an irregular hexagon. Okay. Now let's talk about one more important concept here, which you are pretty much aware of, most of you. So I'm just gonna be drawing it little. Yeah, let's just try to pick it here. So what do we have? So for example, let's talk about do we have a space? Let's try to put it here. Okay, let's try to put it here in this area. I'm gonna be erasing this one for a while and just try to talk about. Next concept we're gonna talk about is for example, you have a triangle, right? And in this triangle, if you carefully observe this, let's say this is the height and this is the base. So in this kind of triangle, if you want to measure the, let's say, the triangle area, the area you are aware of, we calculate like this, half into the base into the height. That's the area. But the important piece is, what is the parameter? What is the parameter of this triangle? Parameter is when you are trying to, let's say this is A, B and C. So parameter will be A plus B plus C. That's the parameter of your triangle. That's the formula that you try to sum it up. Now the similar thing you can apply over the square, only that the square, all the sides are same. So that's gonna be, let's say if the side length is x, then that's gonna be 4x for the parameter, and that's gonna be, let's say x square, x into x is gonna be the area. But there is only one small catch here. Let's say you wanna do it for the let's say you wanna do it for a circle. So for the circle, how do? You are already aware of that. Let's say this is my circle, okay, and that's my radius, okay. Then the area is represented by pi, so that's gonna be pi r square is the area. But what is the circumference? This is not called as parameter, this is called as circumference in the case of circle. So that's gonna be 2 into pi into r. So that's how we're gonna represent. Yeah, that's about it. If you carefully now see that, so we started with specifying the polygons. So polygon, in this case we drew a hexagon which has 6 sides. Then we gave an example of irregular shapes, which are again the polygons. And then we also talk about some of the non-polygonal structures, like how do they look like. Then the third concept we spoke about that, okay, the line of the polygon, the side of the polygon, or from the vertex, you should not be able to reach from the inside of the polygon. If you are able to reach, then that becomes a concave polygon, else it will be a convex polygon. I mean, you can reach, but I'm trying to say that if it goes inside, then that becomes a concave. And then you have the another concept in which, let's say you have a pentagon here which has 5 sides, and then pentagon has all the sides which are same, and if you carefully see that the angles are also same, so then that becomes a if it is also the convex polygon, because any side you extend, it's not gonna be going inside the polygon, then that becomes your regular polygon. The only property that we are looking here is it should be a convex polygon if you want it to be a regular polygon. Yeah, the moment it changes to a concave one, like here, so that's a concave polygon. You see that the point B, when you try to extend, it goes inside the polygon. That's what makes it as concave polygon. And the concave polygon, they are not regular polygons. And then the last one, we have the areas. These are the basic concepts, like the triangle has an area of half of base into the height, and the parameter of triangle is sum of all sides, a plus b plus c. Then you have a circle. You do the area with the help of pi r square, and the circumference is 2 pi r. That's about it.